April 18th, 2024. The interplanetary spacecraft Juno, designed to study Jupiter, flies over the planet's northern polar region. At this moment, the probe captures one of the most unusual images of its entire mission. The image shows a complex system of giant cyclones rotating around a central storm. In visible and infrared light, it appears as a powerful, active vortex. At first glance, everything seemed fairly ordinary, until scientists compared images taken in 3 different spectra: visible, infrared, and microwave. The microwave radiometer, capable of penetrating deep beneath Juniper's clouds, revealed something inexplicable. While the surrounding cyclones emitted intense heat and reached tens of miles deep into the atmosphere, the central storm, the brightest one visually, simply vanished. No heat, no depth, just an outer shell, as if painted on the surface of the clouds. The discrepancy baffled researchers. Why does a storm that appears so active on the outside turn out to be empty inside? How can it even exist without a powerful energy engine within the depths of the atmosphere? One hypothesis is that the structure of the central cyclone is entirely different, unknown to science. Perhaps it's a stable but shallow vortex, whose existence is tied to mechanisms that science has yet to understand. We're witnessing a phenomenon fundamentally different from anything previously observed on gas giants. One thing is certain: on this day, Juno captured more than just a storm. It recorded a mystery that could rewrite our understanding of Jupiter. But this was far from the only discovery that astonished scientists. The Juno spacecraft has been orbiting Jupiter for 9 years, and during that time, it's recorded some truly rare and impressive phenomena. It witnessed the most powerful volcanic eruption in the solar system on the Moon, Io. It observed what happens when massive storms begin to collide in Jupiter's atmosphere, and it captured mysterious structures on the surface of the gas giant's moon, shapes unlike anything we've seen before. The beginning of the mission. The journey to the gas giant wasn't just a long voyage, it was a true engineering odyssey, and a serious challenge for NASA's specialists. On August 5, 2011, the Juno spacecraft set off toward Jupiter. It flew past Mars, and then, after passing beyond the red planet's orbit, it unexpectedly changed course and headed back toward Earth. This unexpected maneuver might seem strange and illogical, but every stage of the flight was carefully calculated and pre-planned. Instead of taking a direct route to Jupiter, NASA engineers used the spacecraft's engine to adjust its trajectory and bring Juno back to Earth. There, thanks to a gravity assist maneuver, Earth acted like a giant space slingshot and accelerated the probe to 16,000 miles per hour, or 4.4 miles per second. That amount of energy was enough to leave the inner part of the solar system and confidently head toward its main goal, Jupiter. On July 5, 2016, nearly 5 years after launch, the spacecraft finally reached its destination. To study the gas giant in detail and uncover its secrets, Juno was placed into an elongated orbit, passing over Jupiter's poles. With each orbit, the spacecraft approaches the planet at a record-breaking distance, just 2,600 miles from its surface, then retreats to about 47,000 miles away. This path allows it to scan Jupiter from various angles and depths, studying its atmosphere, magnetic field, and internal structure. It's thanks to these maneuvers that we received those astonishing images and discoveries that stunned astronomers. Over 9 years, Juno has tirelessly explored Jupiter, sending back data that has continuously reshaped our understanding of the largest planet in the solar system. Its mission is nearing its end, with only a few months remaining. But as it turns out, the spacecraft saved the most intriguing part for last. The latest images and data collected during the final phase have astonished even long-time Jupiter researchers. What lies beneath its dense clouds has proven to be far more complex and dynamic than NASA scientists had previously imagined. Jupiter is the world of chaos. The bright bands of multicolored clouds encircling Jupiter are the planet's famous belts. We see them in every image of the gas giant, but have you ever wondered how deep they go? How far into the planet's interior does this bizarre atmospheric display extend? On September 7th, 2003, during its 54th close flyby, Juno captured this breathtaking image of Jupiter. But it's not just the photo that's important. Gravitational measurements taken by the probe revealed a mystery. These atmospheric belts extend more than 1,800 miles down. For comparison, that's 270 times deeper than the deepest point on Earth, the Mariana Trench. This plunge of jet streams into the planet's depths tell us something remarkable. Jupiter's atmosphere is not just a shell, but an entire world with its own complex and deep circulation system. No other planet in the solar system shows anything like this. Within this atmospheric system exists the well-known storms, so large they could engulf the entire Earth, so powerful they could destroy any spacecraft, so stable they've lasted for decades or even centuries. Seeing these atmospheric phenomena on Jupiter in such incredible detail is amazing in itself, but NASA's Juno spacecraft exceeds all expectations. This image captures atmospheric features as small as 2.5 miles across. The photograph was taken on November the 29th, 2021, when Juno flew over Jupiter's clouds at an altitude of just 3,815 miles during its 38th orbit around the planet. Particularly impressive are the bright cloud domes rising above the giant storm that cast shadows onto the denser cloud layers below, creating a sense of depth and volume. Although these bright features seem tiny next to the storm, each one averages about 30 miles in diameter, the size of an entire city. At the time this image was taken, the spacecraft was only 2,454 miles above Jupiter's clouds, practically skimming the giant's atmosphere. And here, the image shows the planet's northern temperature belt, where zonal winds blow in opposite directions. Their collision spawns vortices of various sizes, from small spirals to enormous storms swirling deep within the atmosphere. Especially interesting are the so-called pop-up clouds, bright, compact cloud formations that appear at the boundaries of atmospheric fronts. Scientists believe these are updrafts of air shooting upward to altitudes where ammonia ice begins to condense. Although they look tiny in the image, each of these cloud fountains can spawn between 50 and 30 miles across. Compared to Earth's atmospheric phenomena, this is immense, but by Jupiter's standards, it's just a minor swirl. To better understand the scale, think of the Great Red Spot, a colossal atmospheric monster. Its current width is about 10,250 miles, enough to swallow both Mercury and Mars. Here you can see the Great Red Spot from an incredible proximity. The image was taken during Juno's 7th orbit, when the probe flew directly over this massive storm. With each new orbit around Jupiter, Juno helps us better understand the planet's complex and powerful atmosphere. Winds, giant vortices, unique in structure and behavior, it all forms a bigger picture that can truly be appreciated only by observing the planet as a whole. This image captures Jupiter's south pole from an altitude of about 32,000 miles. The oval-shaped features you see are polar cyclones, each one over 600 miles in diameter. Io. But Jupiter isn't the only object Juno is studying. A significant part of its mission is focused on the planet's moons, and the spotlight has fallen on Io, the most volcanically active body in the solar system. Imagine a world the size of our moon where over 400 volcanoes spew dust, gas and molten material up to 300 miles high, where lava lakes, fountains and rivers of molten rock cover the surface, and the enormous Jupiter looms ominously close on the horizon. That's Io. The reason behind its violent activity lies in the intense gravitational and tidal forces at play. Io is in orbital resonance with Europa and Ganymede, two of Jupiter's other moons. Their orbits are aligned so precisely that they constantly stretch and compress Io's orbit, causing the moon to be periodically squeezed and stretched. This constant kneading deforms Io, generating internal friction. Combined with Jupiter's pull, it produces tremendous heating within the moon. As a result, Io's surface boils and gases are ejected into space from its atmosphere by powerful eruptions. While at an altitude of 2,400 miles above the surface of the moon, Juno captured 2 volcanic plumes rising above the horizon. This is an animation created from a sequence of images taken by the New Horizons probe during its flyby of Jupiter. These images show the giant plume of the Tvashtar volcano. The probe's camera recorded volcanic material shooting up to a height of 205 miles above the surface. The spectacle resembles a giant fountain, but on a planetary scale and with a force unimaginable by Earth standards. The surface of this fiery world is constantly shifting. It boils, cracks, and is flooded with fresh lava. On the left, you can see the base of the western slope of South Zal Mountain, photographed in 1999 by the Galileo spacecraft. Almost a quarter century later, in 2023, Juno captured a new image of the same region. A widened mountain fissure is now visible, from which molten lava is erupting. In addition to visible light images, Juno used its infrared spectrometer, GRAM, to gain a comprehensive picture of Io's thermal activity. Thanks to this instrument, scientists were able to pinpoint exactly where the most intense volcanic activity is currently happening on the moon. GRAM literally shows where Io is burning the hottest. Each bright spot in these images is not just a speck, but a massive area of volcanic activity. By compiling data from Juno's instruments, NASA scientists were able to create the first detailed map of Io's volcanoes. Special attention is drawn to a region known as Loki Patera, the largest volcanic depression on this moon. Imagine a lake of magma 124 miles in diameter, which is even larger than the crater from the infamous Chicxulub asteroid that wiped out the dinosaurs. This lake is hidden beneath a thin crust, dotted with islands and surrounded by hot flows. But what's truly astonishing isn't just its scale, but also the incredibly smooth surface it has. It's so flat and polished that it can be compared to glass, as if this hellish inferno were a gigantic glass mirror. Another thrilling discovery by the Juno mission is a mountain that scientists have nicknamed Steeple Mountain. It was spotted during close flybys in December 2023 and February 2024, and immediately stood out due to its strange and monumental shape. Amid Io's chaotic landscape, this mountain looks utterly alien, like a giant cathedral carved from volcanic rock. What's especially impressive is its height. From base to summit, Steeple Mountain rises 3 to 4.5 miles. If someone were to step off its edge, in Io's low gravity, the fall would last nearly 1.5 minutes, a true plunge into the abyss. Io is one of the most valuable objects for study in the solar system. It's a place where scientists can observe how colossal gravitational forces literally sculpt the surface of a planetary body. For a long time, researchers could only infer Io's interior based on indirect data and models. But now, thanks to the Juno mission, we've obtained real evidence of what's happening beneath its surface. To do this, the probe used a microwave radiometer, MWR, an instrument originally designed to study Jupiter's atmosphere. However, the team adapted it for Io by supplementing it with data from the GRAM infrared spectrometer. The joint analysis revealed something astonishing. Beneath Io's crust still lie flows of hot, uncooled magma. Research shows that about 10% of the moon's surface contains areas where lava is still slowly cooling beneath the top layer. This explains why Io's surface renews so quickly and offers a key to understanding how internal heat escapes to the outside. In fact, Io's volcanoes and lava channels operate like a giant cooling system. like a car radiator transporting heat from the depths directly into space, where it dissipates into the vacuum. But that's not all. Thanks solely to GRAM data, scientists recorded the largest eruption in the history of Io observations. It began in December 2024 and lasted at least until March. Here you can see how Juno observed this event in the infrared spectrum. The eruption occurred in Io's southern hemisphere, covering an area of about 25,000 square miles, a territory slightly larger than the state of West Virginia, and released energy in the range of 140 to 260 terawatts, several times the output of all Earth's power plants combined. According to the latest estimates, the volcano remains partially active, and the team is eagerly awaiting Juno's next close flyby, where it will pass just 55,000 miles from the Moon to continue studying this truly fiery world. Research on Jupiter. Juno has given us not only stunning images of Jupiter and its moon, but also helped us understand what this gas giant world is really like. Scientists have long known that Jupiter has a strong magnetic field, but the data collected by the spacecraft surprised everyone. In some places, it's 30 times more intense than that of Earth's. This turned out to be much more powerful than scientists had expected. But Juno went further. It helped reveal why Jupiter's magnetic field is so strong. According to the collected data, under the colossal pressure inside the planet, hydrogen turns not just into a liquid, but into liquid metallic hydrogen. In this state, it behaves like a metal. It conducts electricity freely, and scientists believe it's this that generates the giant magnetic field. Thanks to extensive observations and measurements using the MAG instrument, it became clear that the zone where this metallic hydrogen begins lies much closer to the surface than previously thought. This shows that many of the scientists' earlier assumptions about the structure of Jupiter were incorrect, at least until Juno arrived. You've probably heard the saying, the end justifies the means. In the case of the Juno mission, those means were $1 billion and years of work by hundreds of scientists. And the result was worth it. Jupiter became closer, clearer, and more fascinating than ever before. This mission answered questions that had puzzled scientists for decades, since at least 1995, when the Galileo spacecraft dropped a probe into Jupiter's atmosphere. The probe descended for nearly an hour and sent a wealth of data back to Earth. But among all that data was one strange and unexpected fact. The upper layers of the atmosphere turned out to be surprisingly dry. They contained only a tenth of the expected amount of water. At the time, scientists chalked it up to chance, saying the probe had simply landed in an unusually dry spot, a so-called hotspot. But in science, coincidences always raise doubts, and only 25 years later, with the help of Juno, the real cause of this mystery was finally uncovered. It turned out that the region north of Jupiter's equator truly is drier than expected, all because a previously unaccounted for process occurs in that equatorial area. Thanks to Juno, we now know in areas where shallow lightning flashes are observed, water and ammonia combine to form dense clumps, something like ammonia water hail. These pellets become heavy and sink deeper into the atmosphere, carrying moisture and ammonia down from the upper layers. It was precisely these processes that Juno detected in the very area where the Galileo probe once dove, so it wasn't a coincidence or a mistake. On the contrary, the probe was the first to touch a much more complex and unexpected atmospheric dynamic than we had imagined. Juno mission peeks under the surface of Jupiter. Although the Juno mission is already nearing its end, the spacecraft continues to unveil new secrets of Jupiter. Previously, we talked about the mysterious polar cyclones, especially the central cyclone, which surprisingly shows almost no activity in the microwave range. Now, on April the 29th, 2025, the NASA team released new data that adds even more detail. In this image, 8 polar cyclones surrounding the central cyclone are clearly visible. The size of these vortices is astounding. Their diameters range from 1,500 miles to 1,740 miles, which is roughly the distance from the southern tip of Texas to the Canadian border. But this time, thanks to long-term observations using Juno Cam and the infrared camera GRAM, scientists managed to trace how the enormous central cyclone and the surrounding smaller storms interact and move. Unlike hurricanes on Earth, which form independently and quickly dissipate, Jupiter's cyclones are unusually stable. They seem glued to the poles and slowly drift towards the center under the influence of a spatial effect known as beta drift. This process is linked to the planet's rapid rotation and atmospheric circulation. When the cyclones get close, they start pushing off each other like compressed springs. Therefore, they don't merge, but instead form a stable ring around the main storm, gently rotating and oscillating. These new observations help us better understand not only the atmospheric dynamics of Jupiter, but also expand our knowledge of weather processes on other planets, including Earth. In September 2025, after completing its 77th orbit around Jupiter, the Juno mission will come to an end. The spacecraft will be directed straight into the gas giant's atmosphere, where it will burn up as it completes its mission. Over the years of exploration, Juno has radically changed our understanding of Jupiter and its moons, revealing many secrets of this complex planetary system. But, as often happens in science, the answers brought new questions. It turns out that many strange and unusual things are happening on Jupiter. Our solar system began as a disk of dust and gas some 4.6 billion years ago. The first planets to form were the gas giants Neptune, Uranus, Saturn, and Jupiter. Jupiter took shape about the same time as the rest of the solar system, forming around 4.5 billion years ago, its strong gravity pulling in massive amounts of gas and dust from the disk before all the other planets formed. It was the first and the largest. Jupiter is mostly made up of hydrogen and helium, about 90% hydrogen and about 10% helium, almost the same composition as our Sun, which is about 70% hydrogen and 28% helium. Some astronomers call Jupiter a failed star. However, the gas giant only has a mass of 1/1000th that of the Sun. Jupiter just isn't massive enough for gravity to trigger nuclear fusion. The beautiful whirling clouds and storms that you see in images, the layer resting on the surface known as the troposphere, are about 31 miles thick and are made up of ammonia, ammonium hydrosulfide, and water, which form the distinctive red and white bands. When you look at Jupiter, you probably think that it must have a solid surface. The fact is that Jupiter doesn't have a true surface. It's mostly swirling gases and liquids, and if you sent a spacecraft there, it would have nowhere to land. But just because the spacecraft wouldn't have a place to land doesn't mean it would fly right through Jupiter's atmosphere and come out unharmed through the other side. This is because extreme pressures and temperatures deep inside the planet would crush, melt, and vaporize any spacecraft trying to fly into the planet. But we've sent spacecraft to orbit and explore the planet. The $1 billion Juno probe, the farthest space probe ever to be powered by solar arrays, was launched towards Jupiter on August 5, 2011, and arrived in orbit around the planet on July 4, 2016. And what we've discovered and learned about Jupiter is incredible. The newest discovery using data collected from the Juno spacecraft found that the colorful stripes of swirling gas and dust you see in Jupiter's atmosphere were found to run 1,800 miles deep and hold so much gas that the mass is about 3 times that of the entire Earth. These belts of wind flow at speeds of 223 miles per hour and disrupt how mass is spread across the planet. It was also discovered that Jupiter's atmosphere is rotating differently, with zones and bands rotating at speeds that are different by up to 328 feet per second. Those bands on different colors you see are actually traveling in opposite directions. Lighter bands move in the direction of Jupiter's rotation, circling the planet faster than it spins, and the dark-colored bands move slower in the opposite direction and take longer to move around the planet. So how does a giant ball of gas floating around in space stay together and form a planet? The Jovian magnetosphere is the cavity created in the solar wind by Jupiter's powerful magnetic field, ballooning 600,000 to 2 million miles, and tapers into a tadpole-shaped tail extending more than 600 miles behind Jupiter. This magnetosphere is the largest and most powerful of any planetary magnetosphere in the solar system. Jupiter's magnetic field is generated by electrical currents in the planet's outer core, which is composed of liquid metallic hydrogen. This magnetic field was found to be almost 20,000 times as powerful as Earth, and rotates, with the planet sweeping up particles that have an electric charge. The electromagnetic storms they generate are so strong that they can be heard by amateur radio operators on Earth, beamed towards us by plasmas and magnetic field lines. These signals are sometimes even more powerful than radio signals from the Sun. This magnetic field traps swarms of charged particles and accelerates them to very high energies, and creates intense radiation that bombards the innermost of its 67 confirmed and named moons, and would destroy anything that got close. Speaking of Jupiter's moons, scientists have recently discovered an FM signal emanating from one of Jupiter's moons, Ganymede. If you want to see a video about this mysterious signal and Jupiter's giant moons, let us know in the comments. By now you may be wondering, does Jupiter have a solid inner core? Studies have found the planet's interior moves as a single body and behaves as if it were a rigid solid, despite its fluid nature. For now, we simply do not know if Jupiter has a solid core or not, but the Juno spacecraft should be able to help discover this, and what the mass and makeup of this solid core is, if it exists. We do know that at Jupiter's core, whatever it's made of, the pressure is about 100,000 times the pressure on Earth. The Great Red Spot is one of the most iconic features of the planet. It's a massive storm the size of the Earth that's been raging since it was first sighted in 1831. Trapped between two jet streams, it's called an anticyclone that swirls about a center of high atmosphere pressure and rotates in the opposite direction that hurricanes do on Earth. It's the largest storm in the solar system, with wind measured around 400 miles per hour. Compare that to the fastest wind speed ever recorded on Earth of 231 miles per hour. One day this Great Red Spot could end up disappearing completely, and scientists say that it's been shrinking since the 1800s, and may only last another 20 years. NASA's Juno spacecraft was able to snap incredible images of the planet as it passed at 5,600 miles above the giant red spot clouds in July 2017. One of the amazing things that was discovered is that deep in the atmosphere, pressure and temperature increase greatly and compress the hydrogen gas into a liquid. This gives Jupiter the largest ocean in the solar system, which is made of hydrogen instead of water. Juno also grabbed some spectacular images of the gas giant's poles, discovering another incredible wonder of the planet. At the North Pole of Jupiter, a huge persistent cyclone is visible, and encircled by smaller cyclones ranging in size from 2,500 to 2,900 miles. On Jupiter's South Pole, the same thing was discovered as Juno did a flyby, and using infrared cameras imaged a cyclone the size of the entire USA, with 5 other cyclones swirling around it in a geometric pattern, which also rotate counterclockwise. The NASA Galileo spacecraft was likely the first to discover these hotspots when it accidentally flew through one on its way to a planned demise to the surface of Jupiter. When the spacecraft was almost out of fuel, NASA deliberately sent the craft on a no-return plunge into Jupiter on September 21, 2003. This was done to protect the moon Europa, which some say has a subsurface ocean that could contain life. It's worth mentioning that we probably should be thankful for the planet Jupiter's size and the powerful magnetic field that it generates, because it's possible that Jupiter has saved the planet Earth from certain doom. People were laughing at the prospect of an asteroid or comet hitting the Earth in the late 80s and early 1990s, but then something happened that would quiet that laughter. The comet Shoemaker-Levy 9 was discovered by Carolyn and Gene Shoemaker and David Levy on March 18, 1993, using the Schmidt telescope at Mount Palomar. Scientists calculated the comet was originally 1 to 1.2 miles wide. However, tidal forces from Jupiter's powerful gravity had broken the comet into more than 20 pieces as it made its close approach to the planet sometime in 1992. But the biggest revelation was scientists saw that the fragments were going to smash into Jupiter, and luckily for NASA, its Galileo orbiter was still on its way to the gas giant. Many Earth-based telescopes and orbiting spacecraft such as the Hubble telescope all were focused on the incredible event that was about to happen. The fragments of the comet were lined up like a freight train and collided with Jupiter's atmosphere, unleashing the force of 300 million atomic bombs. The fragments created huge dark spots in the clouds that measured 1,200 to 1,900 miles and heated the gas giant's atmosphere to temperatures as hot as 53,000 to 71,000 degrees Fahrenheit. If a comet of this magnitude hit the planet Earth, the results would be devastating, with impacts sending dust and debris into the sky, which would cool the atmosphere and absorb sunlight and envelop the entire planet in darkness. This historic Jupiter comet impact is what led to planetary defense. But fear not, this type of collision was very rare, and scientists say probably only occur every few centuries. Or do they? On August the 7th, an amateur astronomer was looking at Jupiter through his telescope when he captured an asteroid colliding with the atmosphere of Jupiter, creating a white flash visible in the clouds. Some scientists say these impacts are inevitable, with the amount of objects floating around in space and Jupiter's massive gravity tugging on anything that gets close to it. We could say that Jupiter's like Earth's big brother and likely protecting us from asteroid impacts. We've learned some new things about Jupiter and how its layers of atmosphere are made up, and we've also been able to image the planet in striking detail, piecing together images captured at the perfect moment for clarity called lucky imaging. The highest resolution image of Jupiter ever seen has been created in thermal infrared light. In the photos you can see the familiar banding. Bright regions are clear air, where heat from inside the planet can leak out, and darker regions are where the thick clouds block the heat from escaping. This proves that the interior of Jupiter is very hot, heat left over from its formation billions of years ago. When taking a look at Jupiter through the Hubble telescope, what you see is sunlight reflecting off the cloud tops. With these amazing images, we're learning more and more about Jupiter every day. And we're not done yet. Our ancestors knew the monstrous size of Jupiter. The gas giant's mass is 2.5 times the total mass of all the other planets in the solar system, and 317.8 times the mass of the Earth. Jupiter's volume is 1,300 times larger than our planets. But today, we've advanced technologies that help us learn more about the gas giant than just size and mass. And astronomers pay a lot of attention to the study of Jupiter as our planet's future depends on it. The latest data we have shows that, right now, something strange is happening with the planet. Jupiter is considered the super vacuum cleaner of the solar system by astronomers because of its immense gravity well and where it orbits in the inner solar system. The gas giant has taken some huge impacts from asteroids that could have hit Earth in the past, like Shoemaker-Levy 9, which slammed into Jupiter as it broke into pieces in 1994. But the planet's gravity isn't always protecting us. Along with Venus, it affects the Earth's climate. Every 405,000 years, gravitational fluctuations between Earth, Venus, and Jupiter bring us abnormally cold winters and hot summers. Droughts become severe and rains cause floods. Researchers say we're now somewhere in the middle of this cycle, and if something goes wrong on Jupiter, it could affect Earth in a big way. So what is the weird thing going on with Jupiter? For once, its most famous storm seems to be shrinking, and we have no idea how that will affect the planet. The Great Red Spot is a huge anticyclonic storm on Jupiter. The largest storms on Earth are more than 1,600 kilometers across, with winds reaching up to 320 kilometers per hour. But these hurricanes pale in comparison with the Great Red Spot anticyclone, which is about 16,000 kilometers in diameter. The gigantic storm is circling Jupiter at 650 kilometers per hour. Astronomers discovered the Great Red Spot in the 17th century, and scientists still study this phenomenon. The distinctive color of Jupiter's Great Red Spot has been a mystery for a long time. Some scientists believe the storm is colored by complex organic compounds. The whirlwind lifts them from the inside of the planet into the upper layers of the atmosphere. Others think the rusty color comes from sunlight splitting up different chemicals in the anticyclone's upper atmosphere. If so, the storm isn't actually very red at all, and what we might see is just a sort of sunburn at the top of it. Another interesting question is why the anticyclone lasts so long. Scientists have suggested it's because of Jupiter's composition, which is mostly hydrogen and helium. The gas giant has no solid surface to frictionally weaken the storm. On Earth, friction reduces the wind speed near the surface. This slows down storms. But other planets in our solar system aren't like the Earth either. Saturn, for example, isn't rocky, and storms there don't last this long. The biggest storm on Saturn, the Great White Spot, covers several thousand kilometers. You can see it through a telescope as a white oval. This spot appears every 30 years and then vanishes without any trace. The Big Dark Spot on Neptune, which was discovered in 1989, was also proved to be short-lived. The wind around the storm reached supersonic speeds of up to 2,400 kilometers per hour. The large dark spot was constantly changing its shape and size. With that much activity, the storm was clearly not going to subside, and yet, in 1994, it disappeared. But let's get back to the Great Red Spot. The Juno spacecraft passed over the anticyclone twice in 2019. It took images of the storm to help determine its nature. Using Juno's data, scientists compiled a three-dimensional model of Jupiter. It showed that the Great Red Spot extends much deeper than previously thought. On Earth, a storm of this size would rise above the International Space Station. Researchers say that, taken from above, the cyclone looks like a huge pancake, but a really thick one, going 500 kilometers deep into the clouds of Jupiter. This is 50 to 100 times deeper than the Earth's oceans. The storm is powered by atmospheric jets that go far deeper, about 3,000 kilometers. Scientists are still trying to unravel the mechanism behind how these jets move. So far, there's only one clue from the spacecraft data. Atmospheric ammonia gas is moving up and down in the jets. This is very different from the way things happen on Earth. On our planet, atmospheric phenomena are largely driven by water, clouds, condensation, and sunlight. This is what we'd probably see inside the Great Red Spot if we could get there. The gravity there would be intense. The Juno spacecraft passing over the Great Red Spot was like driving a car on a road full of potholes. Radio waves reaching Earth were slightly compressed and stretched. Thanks to this effect, scientists picked up tiny tremors, 0.01 millimeters per second, and were able to calculate the gravity inside the storm. It turned out to be so strong, as if a mysterious planet was hiding at the bottom of the anticyclone. But of course, scientists didn't find any planet there, only a gas surface. Meanwhile, new measurements from the Hubble Space Telescope show that the storm has changed its form from oval to round and shrunk considerably. Previously, 3 Earths would fit inside the monstrous storm, but now only 1. Look at these Hubble telescope images from 1995, 2009, and 2014. You can see how the Great Red Spot has shrunk in just 19 years. So why is the storm on Jupiter shrinking? And do we have anything to worry about if the storm disappears? According to researchers, something in the planet's atmosphere is killing the storm. An unknown force is tearing apart the Great Red Spot. In May 2017, the Gemini North Telescope spotted a small hook-shaped cloud on the west side of the storm, and something else that looked like a wave peeling off its eastern side. The Juno spacecraft also took an image of red flakes flying away from the spot. Researchers confirmed that formations of various shapes actually detach from the Great Red Spot and scatter into space. These huge chunks, up to 100,000 kilometers in size, are about the size of Portugal or Iceland. Computer models show this is a very natural phenomenon for Jupiter's complex atmosphere. It may happen due to the convergence of the Great Red Spot and smaller storms. On Jupiter, anticyclones are attracted to other anticyclones, and opposites, such as cyclones and anticyclones, repel. The merging of anticyclones is a long process. In the beginning, a smaller storm becomes a small bulge closely adjacent to the larger hurricane. Then, the larger storm merges with the smaller one. But when anticyclones meet with cyclones, something different happens. A clockwise rotation of an anticyclone and a counterclockwise rotation of a cyclone first bring them to an abrupt halt. Then the motion resumes with an unimaginable force and scatters the storms in different directions. A small anticyclone wouldn't merge with the Great Red Spot, but shatter into pieces instead. And these pieces of different shapes would then separate from the storm. This is what astronomers believe they are observing. And the Great Red Spot is still shrinking. According to scientists' calculations, it could disappear in about 20 years. Jupiter is unlikely to be affected, but there may be some irreversible processes that the storm was preventing. Only time will tell what will happen when the storm completely disappears. Based on data from the Hubble telescope, the average wind speed around the red spot increased by 8% from 2009 to 2020. And this means the anticyclone isn't losing activity and may increase in size again. Or it could be replaced by another storm. In 2000, 3 small oval white vortexes on the planet merged together. And at the end of 2005, a new hurricane turned red. Astronomers called it the Small Red Spot. In 2006, the Small Red Spot came into contact with the Great Red Spot. Because this was a slight collision, it didn't have any significant effect on the two whirlwinds. But how will the two storms get along in the future? To sort things out, NASA's mission Juno was extended for 5 years in 2021. The spacecraft will monitor mysterious polar cyclones, the planet's magnetosphere, and its incredible red storms. Jupiter continues to be studied by the Hubble and Webb space telescopes, as well as many ground-based observatories. What else could scientists find on the gas giant? And what's in store for the famous Great Red Spot? Let us know what you think in the comments, and be sure to subscribe to the channel so you don't miss out on anything incredible happening in our universe. Thanks for watching.